Well, good morning. Thank you for remotely having me. So today I'll be talking a little bit about some research, which is a chunk of my upcoming dissertation. My upcoming dissertation is not going to be setting any length records, but even the short dissertations, of course, cannot be condensed into a 15 to 20-minute talk. So this really is just kind of a little nibble of what's going on in some of my research. Um, Oops. All right, so we've already seen pretty much this exact question verbatim at least once this conference, as we should expect to see at a conference like this. And there is kind of the general question of, what factors shape writing systems and written language? Why are writing systems the way they are? I also like to extend this question to why aren't they the way they aren't? I think there's a lot of interesting research to be done on kind of the scope of possible writing systems that don't exist and why. And also an idea that we've already seen quite rightfully at this conference so far is kind of the idea of good or bad writing systems. If we don't like terms like good or bad, well, a new term is coming, not a new term. The rest of this talk will have terms other than good or bad. And then, of course, how does this all kind of fit into larger questions of why languages are the way they are? Since I think most of us at this conference probably agree that writing systems are language or are as worthy of study as language, whichever one you prefer. So in the kind of literature and linguistics and cognitive science, there's been a recent kind of surge of work asking whether we can think of whether pressure to communicate efficiently may shape various aspects of language. Um, and because language is a system used for communication, we can kind of think about, well, what are the goals of communication? We want it to be accurate. It's pointless if we cannot convey the meaning. But we also want it to be effortless. We want it to be easy. We want it to be simple. And these goals often conflict. You can make something much more accurate by supplying more and more and more and more detail, but in doing so, that costs more and more and more and more effort. So there's a push and pull to these two goals. Sometimes you get lucky and you get to kind of ace both of them, but not always. The kind of efficiency hypothesis is that we expect languages to trend towards more optimal trade-offs between what we call informativity and simplicity or complexity, which is to say, yes, these two goals kind of conflict with each other, but we can try to find a really good trade-off, not just kind of in a vacuum, but also, relative to any particular amount of informativeness or informativity, how simple can we get it? Relative to any amount of simplicity, how informative can we get it? And so, if the word efficiency is a somewhat vague term in just general speech, but in the context of this kind of research, when we're talking about efficiency, we're talking about kind of how well the system optimizes this informativity, simplicity trade-off. And don't worry, we're getting back to writing systems soon, so don't panic yet. Just for a little bit of context, so this kind of approach, right, is part of broader kind of functionalist approaches to explaining certain typological properties in language, certain usage properties of language. To be clear, I'm not saying that this is like the one true correct way to think about any of these things, but there's been a lot of interesting research and a lot of kind of, at least in my opinion, success in kind of contributing to the broader understanding of what forces shape language, such as with all of these things, things like word length, things like morphology, things like learnability, things like semantic domains. But now back to writing systems, which is what we're really all here for. So some of us may have heard of this term polyvalence, sometimes multivalence, sometimes ambiguity. It's a concept that we've already actually seen at this conference to some extent. But broadly, it's referring to the property present in many writing systems, especially more logographic or morphographic writing systems, that you have kind of many-to-many mappings between your written units and your linguistic information. So in the center here, we have a Sumerian cuneiform character. Its common modern academic name is Ne, or Ne. And I've included a small handful of the words that contain this character in its spelling. For the ones that don't have a spelling underneath them in cuneiform, that means that this one character by itself can be used for that word. So this word by itself can be the word easy, meaning fire, bil, meaning burn, bar, meaning to fire pottery, kum, meaning hot, etc. It also shows up in the spellings of words like melim, which is like kind of a radiant splendor, erin, enemy, or wickedness. It shows up in maybe the most famous, I was going to say the most famous living Sumerian. He's dead, but the most famous Sumerian shows up in certain spellings of his name. Another example, which I think maybe illustrates this even more clearly, here's a nice simple character, which we call ah. And just by itself, you can kind of note some similarities in the meanings and or sounds of the words that are spelled using this character. So it shows up in the word ah, meaning water. It also shows up with unmappable pronunciation in words meaning river and rain. It shows up, it is the also spelling of the word duru, meaning wet, but we also see a more phonographic use. So it's used for various grammatical suffixes, for example, as well as some verbs which are unrelated to water but happen to be homophonous in many cases. In this case, the verb ah or ak, meaning to do. But here's the thing. There are multiple words in Sumerian, by the way, we're in Sumerian in these examples, that are, as far as we know, homophonous with ah. So we have this other character here, for example, which we have to name ah2 because ah1 was already taken. And this shows up as the spelling of the word ah, meaning arm. When the word arm is exceedingly rarely, almost never spelled with the water character, and water is effectively never spelled with this arm character. But we also don't really see the arm character used phonographically for other things either, like grammatical affixes. So this slide, originally I was going to be attending the conference in person. I had to change my travel plans at the last minute, but I had a whole activity mapped out where I brought in these baskets, and I had these flexible objects mapped to sounds and meanings. And I don't think the technology will let us replicate it. So I have a visual representation of it here. The idea is we can think about characters in polyvalent systems, characters or spellings, etc., kind of like buckets or baskets. And the language that we're mapping with this writing system, it has morphemes, it has phonemes, syllables, sound strings, it has kind of more abstract meanings. And we can kind of think about, well, how are we distributing these meanings, these sounds, etc., into our bowls, into our buckets, which are our characters. And it's not mutually exclusive. So I said before that you almost never see kind of unexpected spellings, but sometimes you do. So you could imagine taking the well, water's bad example, taking maybe the arm, or actually no, we can do it with the word meaning do, ok meaning do. This one actually does kind of happen, where usually it's spelled with this middle character, this middle bowl, but occasionally it's spelled with this character. So you can think of, rather than tossing all of the do into the ok bowl, we kind of pair it up and toss some of it into this bowl, some into this bowl. I promise you this activity made more sense in person. All right. But now you'll recall at the beginning of this talk, I was going on about efficiency. Now, all this polyvalence, all this seeming ambiguity intuitively seems very inefficient. The question is it actually? And why is it that we see the distribution of values across written units that we do see as opposed to other distributions? So why is it, for example, that written Sumerian ended up settling pretty consistently on using the water character for the homophonous grammatical affixes, but not the arm character? So this kind of leads to a driving hypothesis, which is, if we really do expect systems of communication, including ancient writing systems, to be efficient, then we see something which seems intuitively inefficient. We want to ask, is it the case that this distribution of values actually in some way aids or is in favor of the efficiency of the system overall, at least relative to certain goals? So you recall that our idea of efficiency is a trade-off between informativity and simplicity, which now I'm calling complexity because it's going to make some later plots a little more visually understandable. So we want to think about, well, how are we gonna measure informativity? How are we going to measure complexity? And when you're talking about a writing system and the polyvalence of a writing system, well, we can think about informativity as how accurate is the retrieval of the correct value when you're reading. If I use some character to write something, is it going to accurately convey what I was hoping to convey with that writing? And we might expect that if we do have a polyvalent system like this, similar if one character can map to multiple morphemes, for example, we might accept those morphemes to have similar meanings or similar sounds. If you think back to that character that meant like fire and burn and hot and all those other things, those are all, transparently semantically related. And then the water character showed up in various water-related words, but also very clearly could just be used phonographically for a bunch of unrelated but phonetically similar words. And then complexity, lots of ways we can think about it. We can think about it visually, how visually complex is a character, the motor complexity, how hard is it to produce, how hard is it to learn or memorize, so you can have a large or small character inventory size. And one other one which I want you to keep in mind also is the kind of material cost, which may seem trivial in modern times with digital storage of information. But in an ancient setting, for example, space is kind of at a premium, and that's something to keep in mind maybe for the development of the system. I'm gonna not dwell too long on these next couple of slides. These are getting to the nitty-gritty actual methods of how I approach this quantifying these concepts, and these are fairly standard information theoretic metrics used in the literature on these on efficiency. But we can kind of measure informativeness relative to, say, the entropy, which is more or less how unexpected something is. So how unexpected is a result. If I give you a character, how unexpected is it that you're going to get meaning A versus meaning B? Mutual information is a more kind of symmetrical general measurement of how much do, say, characters and morphemes identity inform each other. That's going to be a function both of given a morpheme, do I know its spelling? And given a spelling, do I know what it's referring to? And then communicative cost is a slightly more involved explanation, which I will really not get into. But you kind of think about it as at the system level, what is the expected cost of using a character when referring to a referent, or what is the expected cost of referring to a referent generally? For those of you who are curious, this is the kind of rough formula involved in these things, but of course, I think it's not particularly critical to understanding what I'm hoping to convey with this talk right now. And then complexity. I've just been using these pretty simple measures. So strokes, you can measure it as strokes of the entire corpus, as long as you keep the corpus size constant, or characters similarly, or you can do it like strokes per morpheme. I'm doing per morpheme, not per word, because we're dealing with a kind of heavily morphographic writing system. There are various other ways of dealing with complexity, which I mentioned earlier. So things like parametric complexity for the visual complexity. Those are options which I haven't been using, but are very much good choices to use for things like this. Things like strokes kind of, you could argue, approximate visual complexity. Certainly is a good measurement of motor effort, which matters as well. So as you probably figured out, I care about Sumerian. I also care about Japanese. That'll come a little bit later. But the kind of primary case study for this particular question, it's about polyvalence, and Sumerian is, dare I say, notoriously polyvalent for those who have had to study it in an academic context. So I'm using Sumerian data from what's called the Ur-3 administrative corpus from, I should have put that on the slide, from ORAC, the Open Richly Annotated Cuneiform corpus. The reason for using this particular corpus is combination of size. It's more or less the largest single genre Sumerian text corpus that there is. And the kind of the temporality of it. So these documents come from roughly 1,000 years after the earliest writing. So if efficiency pressures apply to writing systems, we would expect 1,000 years to be enough time to begin to see evidence of that. And then there's various other processing that had to be done because ORAC is a wonderful corpus and wonderful resource, but it is not perfectly suited to all needs. So there had to be some additional post-processing, but you end up with a almost miraculously large number, corpus size for a very ancient language and writing system. Don't worry about these numbers. So the reason I have this slide up here, intentionally kind of incomprehensible, is to drive home a point that I can show you all these numbers, which are the results. These are the real results. But like, what do these numbers even mean? So this is one more point for efficiency, which is that when we're measuring efficiency, it has to be relative to something. If I just say the informativeness score is A and the complexity score is B, well, okay, we care not about those individual numbers, we care about their trade-off. We need to compare it against something to see is the system actually performing better than the alternatives? If yes, that seems to be a sign that it is being pressured by efficient communication, because look, it could have been so much worse, but it wasn't. And one way to do this is to generate random systems out of the existing system, such as by randomly reassigning character values or generating new spellings according to existing graphtactic probabilities. So this gives you a random baseline, which is a good starting point. If the system cannot be more efficient than the random baseline, then that is very concerning, the efficiency hypothesis. But we have to start somewhere, so we start with the competitor that we are most confident will be beaten. And then when it is, and spoiler alert, it is, now we can start comparing the system to much more optimized systems. So we can create these competitors by, say, reworking the existing writing system to maximize spelling sound consistency or spelling morpheme consistency. We can take this system, which is all, this is all about polyvalence. So we can take this thoroughly non-isomorphic writing system and force it to be isomorphic and see how that compares. You can always pick the simplest spelling and try to optimize for complexity. So there are all these things that you can do, and the question is, at what cost is that optimization process when you compare? And of course, you also want to compare with other actual writing systems. So a whole other half of this tiny chunk of the dissertation is about Japanese, which didn't get included here, but that's a good point of comparison because it happens to be typologically similar in terms of the writing system and elements of the spoken language. And then you can also compare, again, hypothetically, you can say, well, what if Sumerian had developed a more phonographic writing system? How would that compare to the actual Sumerian writing system? And I'm not going to dwell too long on results. The results are far beyond what is on these slides, but just to give you a kind of visual sense of what this kind of approach looks like when you look at the results. So on these plots, our y-axis is a communicative cost measure, so it's how informative the system is, such that a higher number is worse. So you can think about it as like more error going up, less error going down. And then complexity, going to the right is more complex and going to the left is less complex. So what you're seeing here there's two plots with slightly varying conditions, for example. We can see how semantically informative written Sumerian is as compared to, for example, kind of plausible, not totally random, but kind of plausible competitor systems that were, say, more phonographic. And we'll notice that as compared to the more phonographic alternate, the real system, which is the dot in the lower left-hand corner, performs better on both metrics. It's both more semantically informative and it is far less complex. But if we compare the real system to these more phonographized system relative to its phonological communicative costs, so how costly is it to refer to sound in this system, the real system does worse. So can we say the system is more or less efficient? Well, we can't tell from this plot alone, but what's telling is that you do still have this huge complexity decrease. So even relative to these very plausible phonographic hypothetical Sumerians that would have been slightly better for conveying sounds, the real system isn't as good for conveying sounds, but has is much simpler, takes much less text to when you're writing. And then here's comparison visuals with Japanese, just to give a sense of kind of the range of these things. So I'm almost certainly long out of time. And of course, what little pieces I've shown you here are not enough to convince you of any broad conclusions. But yeah, the evidence suggests that yes, if we look at the real systems measured in this way, there does seem to be some evidence that maybe this is more efficient than a lot of plausible options. So it performs better in various ways against, say, a completely isomorphic competitor, which gets rid of polyvalence entirely. So I think maybe one thing I hope people take away from this is that when you see something which seems so intuitively bad about a writing system, um, there are ways to think about it which may reveal that there are kind of certain things being optimized or certain things being prioritized. For example, when we looked at that hypothetical versus real for Sumerian, there was that one comparison where the real system wasn't as informative, but it was much simpler, which does seem to be consistent with the idea that relative to Sumerian material culture, where space is maybe at a premium, you want your receipts to be small little clay tablets. That suggests that kind of prioritization of complexity, even if it's at the cost of some informativeness. So with that, I will stop talking. Feel free to get in touch if you have any questions or anything like that. Thank you.
Thank you. I have two questions. One is about the graphs you showed,
Mhm.
the two axes. In both cases, the actual values on the axis are very, very narrow, from 9 to 10, or from 6 to 7, or from 19 to 20. Or it's actually, but you said that it's much simpler or much more complex, or so. So looking at the numbers, it looks to me like a very small difference, although, I mean, it's clearly separated, but it looks like a very small difference.
Yeah, that's a good point. And so it's definitely true. So with regard, for example, to the x-axis on these plots, it's a logarithm of a very large number. So this compresses it visually a little bit. This is a difference of like tens of thousands between the red dot and the blue dot here, for example. But yeah, so when we're talking about when we're talking about, much better, much worse, this is why the comparison is so important and why you want to kind of get a scope of all the possibilities. So when we're comparing, say, the red dot against the blue dot here, or maybe here, um, ideally you run these generative, you generate these systems such that you have like a massive, massive, massive cloud. And this is just a little kind of sample for visual clarity. Um, but you generate a whole bunch of these systems, and you get a sense of how well does the real system compare against all of the other things that could, with any remote plausibility, have occurred. And it's true that the red dot isn't going to be close to like 0, 0. It's not going to be close to the origin on a plot like this. Um, but what kind of matters most is how does it stack up against the possible competition? Because the question is it as good as it kind of could have been? But your point is very much a good one, and that yes, these plots are actually a little bit misleading.
Okay, good. Right. The second question would be, I mean, even in Japanese, sometimes even natives don't really actually agree or are sure how to read some character, yeah?
Mm.
So for this old Sumerian, where you don't have any Sumerian natives anymore, and how, how are you sure, even close to sure, that this character in this specific document instance is actually read as this and means this, which it seems that that's what you need to actually do your statistics.
Yeah, no, that's a great point. Yes, there is. I think whenever someone gives a talk on Sumerian, for example, I agree. Actually, that's important to have a disclaimer that it is kind of a miracle that we understand Sumerian as well as we do, but we don't understand it obviously as well as we understand any modern language. Um, and I would say my answer to that point is, there are plenty of scholars that work on Sumerian, and at some level, I think you kind of have to trust the expert's judgment, which we know might not be correct. I mentioned earlier that the corpus need a lot of cleaning. This is because there are inconsistencies, as you might expect, in how things are glossed and termed. But we do have a slightly better understanding of Sumerian than one might guess. And given especially the kind of historical significance of the Sumerian writing system relative to the origin of writing, at least chronologically, um, I think it would be a shame not to apply studies like this to Sumerian just because the understanding is imperfect, because the understanding never will be perfect. And it's pretty good right now. But it's true that it's not perfect.
And we have a last question online by Christian Border. Some cuneiform signs represent a letter, some a syllable. How many represent a one letter sound?
Oh, that's a great question. So in Sumerian cuneiform, it depends a little bit on how you want to analyze it, but characters minimally map either to a unpronounced unit of semantics or to a syllable. So it can map to a single segment if that segment is a vowel nucleus of a syllable. But otherwise, characters only map to at least a syllable, sometimes multiple syllables, often entire morphemes, or sometimes to ostensibly unpronounced information.